just as an overview, we're going to go over stormwater as a resource and bioretention, some basics about bioretention. And then we're going to go into the specifics of design and engineering, and also construction.
Yes. So just as a reminder, I'm sure everyone's familiar with the hydrologic cycle, and everyone heard Michelle's lecture this morning on the Stroud Water Research Center, so you'll see some of the same images here. But just as a reminder of why we're doing what we're doing in terms of stormwater management, at Mallior we try to look at replicating the natural hydrologic cycle, and you know, basically we have precipitation hitting the ground, a lot of it soaks in, we have evapotranspiration going back to the atmosphere, and that feeds all of our stream systems. So that's really the basis for our designs. Oh, this thing's not working. Okay. So when we look at stormwater management in our designs, we look at small storms for two reasons. One is because the most frequent storms are an inch or less, and also the volume of storms is typically 2 inches or less. So we're looking at managing small storms rather than large 100-year events. You saw this earlier in the natural water balance. When you have a forest, water infiltrates into the ground, feeds stream-based flow, feeds plants, and you have very little runoff. And this is important for both groundwater extraction when you have wells to provide water supplies to people, but also feeds our streams. So when you start to cover our surfaces with impervious surfaces, you change the natural hydrologic cycle. And this is the Philadelphia region, obviously. When that happens, you lose your groundwater recharge. Most of your water runs off the surface of your site, and that can exacerbate flooding and reduce your stream-based flow.
This is an image of the Delaware River watershed, just to give some context. And the star is where our project is. And it's in the Newton Creek watershed, right here, and Cherry Hill's right here, and Philadelphia is here. And it's a typical suburban area that includes shopping centers, and Sadler's Woods is sitting right here, right in the middle of this area. And it's a beloved piece of old growth that also has some historical value. So as Altra mentioned, a typical rural type of situation would have perhaps 10% runoff, but in a more urban area, it can be up to 55% runoff. And so what it does is it starts to really damage the streams, and this is what's going on in Sadler's Woods. So this is just a great diagram showing how a stable condition with the floodplain, it incisors down. All this soil gets washed down into the receiving streams, and it's a big pollution problem. So over at Sadler's Woods, there's gullies like this, and there are some that are 25 feet deep, so it's bad there. What that does, it sucks the groundwater out of the ground, and the trees that grew up with a reasonable groundwater table start to decline. And it's been untouched and untilled, so it's a pretty precious spot. So a few years ago, Cahill Associates did a stormwater management plan, and I don't expect you to read the fine print, but right here is our project here. So they're dumping. It's typical. No stormwater retention, and this school was a big factor. This is actually the watershed outline here of one watershed, and there's another large watershed here that dumps water right into the main piece of, oops, sorry, it's right here, of Sadler's Run. It goes into Newton Creek, down through Camden, into the Delaware River. So it's large neighborhoods.
So it went into the, I saw the Cooper River on the map, so.
Yeah, so Cooper's up here, and so this is the Newton.
You can see a lot of the flow comes from paved areas above this.
Yeah, right. Okay. So just a quick overview of bioretention. This is a good definition I found. It's water quality and water quantity, mostly quality. You have a little bit of quantity control, and it uses chemical, biological, and physical properties of plants, microbes, and soils for removal of pollutants from stormwater runoff. So there's two basic designs. One is with an underdrain and one without. And it's not much more difficult than that. It's all variations on a theme. So this is the one with an underdrain, and that's the one without. It's important to have percolation. If you don't have percolation, then usually you have to have an underdrain or just a secondary method. So at Van Skyver School, this is a picture from this winter, and just to give a quick view of different ways bioretention systems can look. These are different projects. That's at Morris Arboretum. Jonathan Holston, Landscape Architects, Project Computers. So bioretention systems that can reduce runoff volume, filter pollutants, recharge groundwater, reduce stormwater temperature impacts, enhance evapotranspiration, enhance aesthetics, and enhance habitat. The soil depth, generally 18 inches. If it's in your own backyard, maybe it's just your existing soils are good enough. So your depth is just whatever you have. But for engineered systems, they tend to be 18 inches, 36 inches deep for the engineered soil mix. A bioretention soil can be loam or sandy loam. It has to be able to support plant growth. There's so many different ways to do it, so I'm going to show three. This is using existing topsoil that has perhaps a 5 to 10% clay, and typically topsoil has 2 or 3 or 5% organic matter. And a pH of 5.5 to 6.5 is best for pollutant removal. Up to 7 is fine. And typically blending in composted or organic really works well. So it's just simple. Start with a soil that doesn't have too much clay and silt in it, and add organic matter. Soils may be blended off-site and brought in, but that's an energy problem because you're scooping out all your soil, then you have to go dump it someplace or create a berm and come in with all new soil. So I like to avoid that, if at all possible. But this is one recipe for bringing in new materials: sand, topsoil, and compost. For, like I was saying, for backyard rain garden, many of the soils that we have already are good. And this is another recipe here, which is just compost and mineral aggregate, which is a blend of sand and silt, and just a little bit of clay. So that's a technical spec for it. Wanted to mention that the most important thing to start out with is infiltration testing. So find out if it'll infiltrate. If it's about a ½ inch per hour, that's okay. Higher is much better, but a ½ inch per hour, construction techniques could cause compaction of the soil and just cause problems. So it's important to find out what it is. This is a double ring infiltration test. And the trick is to check the infiltration at the level of the intended bottom of the bioretention area. This is deeper just to check what's underneath it to see if there's a lens of clay or high water table. And test the soil too. At Van Skyver School bioretention area, we did 3 tests, topsoil and then in 2 locations. So the topsoil came out with a clay of about 12%, that wasn't bad. The pit east of the school had clay up at 23%, which was too high for reasonable infiltration. And Meliora found that the infiltration rate was ½ inch per hour. So that was on the edge there. The pit north of the school had clay at 8%, and the infiltration rate was 1.44. So we learned a lot there, and it adjusted how deep the different sections of the bioretention area. So we had 4 different bays, and we made the ones with the sand deeper, holding the water, so they held a deeper depth. We also swapped sand out and moved it over to the clay area, and I'll let Peter talk more about that.
Typical to have such a disparity among?
No. It's usually here, just like use a soils map. Yeah, so that's a real good lesson learned, is do the tests right where you're going to be. But we were shocked. We were absolutely shocked. If an underdrain is needed, for instance, here at Clement Park in Redmond Township, there was no infiltration here. It was all filled soils. So we put in an underdrain. Typically, one would think of an underdrain having to come out of air and you need lower ground. But there's another technique, you can bring that under drain up just a little bit so that it can fill up inside and it can be saturated. It's a new technique, it doesn't show up in the books yet. And so then the bottom here would get a little saturated for a long time. And this was about 4 foot depth of soil, so there was.
Is that a perforated pipe?
Yeah, I should mention that. That's a black perforated pipe. And these socks, you just buy them 100-foot lengths. So it's a real simple way to do it. I wanted to do this one just low tech. It was Boy Scouts putting it in. So we just put the sock on the pipe, put sand over it, filled it.
I'm curious only because I don't see any fabric.
Yeah.
That is
brilliant.
Right?
What's that?
Oh, you meant,
This fabric or on the right around the pipe.
I knew they did that. Because I was thinking that with a larger pit, if you had the pit fabric, you give more chance for the water to enter the pit. Then you not have to get to the pipe, but at least then the pit itself isn't filling up with soil over time.
how would you?
If you had,
Do you understand?
Yeah, you're talking about the migration of the smaller particles?
right, so in other words, if you surrounded that pipe with stone,
Mm-hmm.
over time,
That's right.
the little soil would, filter into the stone and clog up the stone. And I was just figuring that you could do both, but
You could.
maybe you have some better idea now.
Yeah, the standard detail from NJDEP showed fabric. So there would be sand and also fabric and then the gravel. So there's different techniques, and this is a low-cost way to do it.
Okay.
And you can see the pipes are very close together here, because it's a 100-foot roll with a small little rain garden, so it's really well drained.
And you still expect that to last?
Oh, yeah.
The plants will too.
Pardon?
The plants, and this is a rainwater month, so
That's right.
the plants will help.
Yeah, okay.
And then just like to have a stub out, just to check. So this is coming up right here, which this corner is right here. And we put a little clean out cap so we can check to see what the saturation is underneath there. And if it ever has to get rooted, this is how to do it.
Oh,
You don't see that.
yeah, I wasn't expecting that.
Yeah. So Alcha will get into the design engineering.
So you can just hide that clean out among the plants then?
That's it. That's it.
Okay, so we worked with the Riverkeeper to come up with the design for Sadler's Woods. And as we mentioned, it's adjacent to the Van Sciver Elementary School. It was very close to the school. And whenever you're designing around children, you have special considerations to take into account. But basically, the design is that water enters the rain garden system. It's a system of swales and bioretention pools, and it enters through 2 trench drains, and then travels through the series of pools over some earthen berms that are capped with fieldstone, and it makes a tight curve around the side of the school, and then eventually overflows into Sadler's Woods.
What kind of rainfall would wind up overflowing?
Well, we'll get to that. The system was designed to manage the 1-inch storm, like I mentioned, a small storm event. But it does take over nearly 3/4 of an acre of drainage area, of impervious area, over a half an acre of drainage from Rhodes Avenue here. And then there was an existing inlet right here that was very shallow and couldn't handle the flows that were coming to it. The school was experiencing flooding problems, icing problems in their main drop-off area there. There's also an existing parking lot that had a low point in the corner that had no inlet. So there was flooding issues there too. So it was our idea to put trench drains at those 2 locations to let water through the sidewalk and into this system. The system's able to hold over 2,000 cubic feet of water, which is the equivalent of about 330 bathtubs. We won't get too technical here. This is the grading plan. I guess want to mention that we were constricted a little bit with the archaeology of the site, which I believe John will go into a bit later. But we had a small footprint, but we were able to grade this in such a way very carefully that we stayed within the footprint and met our management goals. Some interesting things about the design, were that these first two pools were graded so that they had a 1% slope continuous throughout. There's not a lot of ponding happening here for a couple reasons. One, we had just had a project constructed that I'll show pictures of later that had a problem with the soils. So we were a little bit scarred from that, and we didn't want to have ponding water right in front of the school, and also because we had the lower infiltration rates in the front of the school, as John mentioned. So we keep water moving continuously at 1% through the swales, through the pools, and around the side of the building. And in the back two pools, we allow 6 inches of ponding. Now we'll get into a little more of the details. Here's one of the trench drains, and they go through the existing sidewalk onto some very attractive stone cobble splash blocks to dissipate the flow. This one actually had quite a bit of drop and looks very nice when water's flowing through it. The vegetated swales, we reinforced these with a permanent erosion control blanket. There's 2 different kinds of blankets. This one, because there's a higher velocity moving through a smaller channel, we wanted to put something permanent in there. And it did become very important, as you'll see in some later pictures, to have that. We used the North American Green SC250 mat. It's supposed to hold flows of 9 feet per second or 15 feet per second if it's vegetated. The swales are 6 feet wide, and we kept a gentle 3-to-1 side slope on the side. So you can see them being constructed. They are pretty gently graded into the landscape there. This is our typical bioretention pool cross section. John will get more into the soils, and Peter too, about how we mix those, but this uses a different kind of blanket. It's a temporary blanket, but by temporary they mean it's going to last about 12 months, and it still maintains a 5 foot per second flow.
Is that what you see in the picture there?
That's the blanket that's coating it in here. And some of the important details of the blanket is keying it into the soil to make sure that it doesn't come out. This is showing 6 inches of ponding, but those are for the back, and then, as I said, we have 1%. These are the 2 pools in the front during construction, I believe. Some of the notes that we put on the drawings to protect the system were to hand excavate or use your equipment on the outside of the pools. At the time, we weren't sure who was going to be building it yet, so we always try to be careful with putting those sorts of notes on the plans. If you have a good contractor that you know is going to be careful, it's not such a concern, but a lot of times you don't know who's going to build it, so you want to be as careful as you can. This is the detail for the stone check dam and weir. So these provide multiple purposes. They allow the ponding in each green garden pool, but they also allow access into the pools for maintenance and allow the children to access them for education, and without getting soggy. So we considered earthen berms, but this maintains a hard surface that folks can walk across. So this is really the main spillway where water travels between the pools during rain events. There are 2 overflows from the system. One is for small storms, which is what we typically get. So this is the low flow outflow level spreader. We used, in this case, 2 pieces of perforated pipe here and here, and they're dressed in stone. So basically, you just have one long perforated pipe here, and then perpendicular to that, you have your solid pipe through the edge of the rain garden, and then it outflows very nicely here, so you don't have any point discharges. Everything's dispersed. Now, for heavier rain events, this is not going to be able to handle it, and we wanted to direct the water away from, this is an adjacent soccer field, and we wanted to direct the water away from that, away from where the children were playing. So we planned for an emergency surface overflow, which became needed much earlier than we had anticipated. So it's working, and basically that's just at the surface. We had an outer rim that built up our berm for our final pool, but we graded in a 2 foot wide emergency spillway to direct the water again towards the woods and away from the play area. Now, yeah, this is, I don't know exactly when this storm was, but
it was a freak thunderstorm.
Yeah,
it was in May.
So how long had you been in place at that point? Looks like 2
It
weeks
was during
ago.
No, we just got the fabric down.
Yeah, this is, just got the fabric down, so just in the nick of time, but this was a pretty large storm event. And we were very happy that everything held up.
And we used the staple pattern that you're supposed to use.
And you know, typically you want to prevent water from coming into your system until it's fully established. And we had erosion control devices in place, but just the nature of the storm, it was so big that it overtopped the sidewalks and water entered it, you know, regardless of our ENS controls. So.
Well, congratulations.
Just to give a couple examples of other rain gardens, these are more of an urban setting. This is at the Independence Charter School, and actually Think Green built this also. This is a cobble swale that directs water from these impervious surfaces in this play yard into this small bioretention area. And this is another, I'm showing this also because this is another type of overflow from a system. A lot of times we use a domed riser overflow rather than the perforated pipe level spreader. And this connects, this is in the city of Philadelphia. All of these examples are actually, and this connects directly to the sewer system once it overflows. So even in these tight constrained spaces, these are possible at schools. And this is an example of a bioretention system we had done prior that kind of informed the Sadler's design. This is at Fairmount Park, adjacent to the Bluebell Tavern. But again, it's a series of pools. We designed it originally to travel through a trench drain to keep everything very shallow and bring water into the park from the street. However, when we started to try to go through permitting, the streets department wasn't happy with the trench drain across the street because of plowing. So we had to modify the design to have inlets bring the water in a little bit deeper. But anyway, this is just another example of, it's going to be built this spring, I believe. And then folks might be familiar with the Greenfield Charter School. This is PWD's, one of their pilot projects, and another site where you have a lot of impervious surface at a school site coming to a bioretention cell system that flows through the site. And in addition, there was a porous play surface with play mounds, just a nice amenity for this very urban school. It was 100% impervious play yard prior to this design being installed. This is a section view showing water coming down across the impervious surfaces and into the bioretention system. One of the interesting parts of the design that actually the children came up with during a charrette was this climbing structure that serves the purpose of both being a play structure and also preventing you know, basketballs and such going into the bioretention area to protect the plants from the children, and they came up with that themselves. So. And
that one works. Where that is, it works. Where it
Yeah.
isn't, the kids do play in there, but they've been pretty good.
And this is an image of the Greenfield School before construction. And then this is shortly after it was planted. They put little buckets next to the trees so that the children all took stewardship roles and filled up their bucket and watered their tree every day. So.
And that was where we had to manufacture soil for that one.
Right.
The soils were unsuitable, so they're like 3.5 feet deep in 2 layers. We worked on that one too.
Yeah. This is the last other example I'm going to show before we return back to Van Sciver, but this is the case where I said we were scarred a little bit in our in the installation of this rain garden. It's at the Ralston House, which is part of the University of Pennsylvania. This is a rain garden design that was meant to take, there's a, off the page here, a bluestone slab sidewalk, and then a lot of lawn running here. But they were very particular at the site, and they did not want ponding water. They wanted the rain garden to function, they wanted the soils to absorb the water, but they really didn't want any ponding water whatsoever. But during construction, something happened. I wasn't on site. I don't know exactly, but either the soil mix was wrong or the soils were compacted by the equipment, or maybe a combination of both. But this just turned into basically a clay lens. And I went out, you know, after several days, water would still be sitting here. It also looks like the domed riser was set up a little higher than it had been intended, or the soil settled. I went out here with a soil auger and poked a hole in it, and water or air came bubbling up, because there is a stone bed below here also. So it wasn't making it to the stone. So to remedy this issue, because it was a major issue. They were very angry with us about the bonding water. We installed a perforated pipe with just stone in it, wrapped in a sock, to make a direct connection between the bed and the stone below. And also, the domed riser was excavated out and holes were drilled in it to allow water to go down there. So, simple solution. We were worried we'd have to tear the whole thing out and redo all of the soils, but that was a simple solution to that problem.
The planting design now. At the Van Sciver School, this is the concept plan, where it's the 4 bays. And Jonathan Alderson, landscape architects, were landscape architects. Typically, before doing planting design, you look at the region where you are. And this project is in the intercoastal plain, and species tend to be similar in the intercoastal plain. Up and down, even down to North Carolina, there's similar species. One looks at the soils and the geology, and looks up references. So, for instance, Plant Communities in New Jersey was used as one reference, and there's plenty of, at the end of the slideshow, I have more references. You can write things down. For this project, it was chosen to have regionally native species adapted and useful for habitat and education. And it had to be low maintenance. There was nobody who was volunteering to maintain this. There was an active group. They were already maintaining their butterfly garden. The teacher was going to be retiring soon, so this had to work and not be high maintenance. The species in a rain garden have to be adapted to wet and dry. And on this project, typically the planting needs to be short enough, not the trees, but to just have some visibility. And the layout had to be beautiful. It was right next to the school. It couldn't just be something out in the woods that didn't work. This had to work from day one. So here's the plant list. You can always look it up. This will be videotaped, and you can look this one up later. And so we had the initial planting, and later in the fall. So last spring it was planted, and then in the fall we came in and we were able to add in some more. And then grasses are an important part of the design. We use a special technique on this one project where we wanted easy maintenance. Anybody who's maintained a rain garden, you see a sprout, you don't know what it is. You don't know if it's a planting one or not. So we decided to go with the grasses and then just 5 species of perennials. We also had a seed mix in there with some just grasses. So we had 5 species of perennials that went in there and just chose a season for each one, made sure it was a school, so it would be spring and fall. Most things are in the summer. So we made sure to have the iris for the spring. Swamp mint would be a little bit more in the summer. Black-eyed Susan would last till the fall, and New York Aster in the fall. So we started with those. And we supplemented in this fall with some more plants once it was established. So the grasses came up great. We had a very low weed problem. It was the most amazing thing I'd ever seen. There were some weed grasses, but we overlooked them. Most people can't tell the difference between a native grass and a non-native grass. And I could tell. One of the things that came up the most was nut sedge, which is sometimes native, sometimes not. So looked it up, okay, we got a native plant. And so we added some more species for color. These will be sprouting this spring. But just a basic guidelines. Riparian and floodplain species are perfect for rain gardens usually. Despite what you read online, don't put in wetland plants. A lot of the rain garden designs include wetland plants. And if it's an obligate wetland species, just avoid it. Generalist species do real well. Switchgrass can handle salt or no salt, dry, wet. Red maple can handle all kinds of wet or dry conditions. Include warm and cool season grasses, and include forbs. The cool season grasses jump in the early spring, and usually the forbs, the perennials, they jump in the early spring too, so they fill that ecological niche. There's also a lot of research on how deep the roots go and get plants with different depths of roots. And also, just going back, a good way to start a design is to find a reference plant community. You have to have a good book to do that, or a good location nearby. But the problem is rain gardens aren't real common in nature, so you have to adjust that. Start with the reference plant community, but then expand the palette. These are just some quick images. I'm not going to go through all the plans. We'll be able, so we can have some time for construction. But these are just some quick images of species that can be used in rain gardens. Certain shrubs, grasses, seasonal interest in construction.
Hi, everybody. My name is Peter Johnson. I am a principal and partner at Think Green LLC. My partner, Tom Johnston, and I founded in 2003. We've had the luxury of working with John since, I think I've worked with him since '95, and Watershed and Meliora since for a long time also. We are a landscape architecture and construction company. We do landscape architecture, we do design build, we do bid build. So this is a bid build. We worked closely with them for this. It's always important to get a benchmark on this site. This is not heavy excavation. You know, we were shaping the land, and we did soil swaps in certain areas, like he was talking about. There was clay that we took and excavated out to put in the bottom of the berm to hold the water at the lowest portion of the site where you saw the overflows. So the benchmark and the laser, tight constraint too. At that corner, we only had about 12 to 15 feet. Okay, so we had to make some modifications to make the swale go around the building. Also creates issues of construction sequence. So what we did is, here's where we started. We set stake grades all the way through and a line through the site and worked our way off those stake grades for offsets. We dug what is like a borrow pit. There was a gas line running through the site, so we picked that location to hand dig, find the gas line, so we made sure we knew where that was, and then because we had to do a certain amount of excavation, and we would find that gas line. We actually dug a borrow pit that took all that clay. Took all the clay out of that, correct? And then
In a certain trench to improve the infiltration.
right. So we took it from here. To improve the infiltration on the upper basins, we did this long linear trench. So the trench actually came from here to here, or through the section of those two upper basins. And we took that soil and put it in the berm below. That was the pit. We weren't into the gas line at a certain depth. John and I had decided on a certain depth of what we were going to excavate. So that trench went 20 feet, 20, 30 feet in one direction, 20 feet to 30 feet in another direction. We took an approach here. Again, compaction was important. What equipment we used, it was all track machines. We had a designated kind of line of where we tried to go with our equipment, where we knew it was flow and not infiltration. So that's how we were able to work our way out of the site. We started from downhill and worked our way up. So this actually, we used a soil blender to actually deal with the turf in this case. Got all of this.
Can you describe that? I'm not sure what you're
I'll explain it. It's a tube with knuckles on it. Spins at a very high rate. And basically we're able to scrape off the sod without disposing it, like having to haul it off to a landfill. We're able to use that, shake it, get as much of the soil out of that to actually reuse the soil. So there's where, that's a stockpile of the soil that we got out of that. And we composted the grass clippings. Basically we got it down to turf. We had done the excavation, we worked our way from here. You can see the grade stakes throughout the project the entire time. Also the site constraints. We actually had protection fence up for the kids. And when we were working, the bulk of our work had to happen over spring break. Our major excavations.
Summer.
Yeah, our spring break of last year. So to put in perspective, spring break of last year, we did our heavy machinery work as much as possible, and then, which was a lot of work real quick. So here you see, I just wanted to show you sediment erosion control devices. There's the mulch sock, right, silt sock, and we decided that we had to use a silt fence all around the site so that we showcase the whole site. So you start to see the swale being shaped. Those stakes stayed throughout. The reality is all the water went here during the project. So we had a little dewatering to do, but we had protected the outflow with fabric and rock on top. So we actually laid fabric over our built structure that has the pipe in it for drainage, and we laid that on top, put rock on top, so that we had a second layer of defense. So when we were done, we pull it off, cut all the fabric that was through it, and pull it away. Because obviously we weren't done yet. So there it is. You can see the fabrics, we can pull it. And that's the outflow. That's when we dewatered it. That was that day.
You said dewater, that mean pumping out?
Yeah, we had to pump it through. We had it, inside the silt fence area, so it would slowly go back where it was supposed, where it would end up eventually. So get a bunch of stone. It's Pennsylvania stone, local. It's within probably 60 miles of the site. And then we made the weirs. Set up stone, our company, our masons that we've trained. Started to make the earth berms. Again, trying to minimize, where we're going with the machines and also the access. So this is where I'm talking about. We didn't cut the concrete out. You can see it's blocking it. That's the swale. That's the beginning of it. You can see that the water filled it. The water actually, every time there was a major event, actually just went right over the sidewalk. That's how much water they would get. This was towards the end when we actually did cut through at one of the structures, and we started to place, inscribe the boulders and the stonework to the concrete work. So it is retrofit to an existing condition. Soil blending, composted leaf mulch. We get certified composted leaf mulch. It's weed-free, makes our life easier. We work with a great supplier. You can get it from townships and things. In this case, we didn't do that. You just have to be careful when you're composting because you're going to end up with, you can end up with a lot of weeds at times. So we take this, lay it over the entire site, blend it with that tube that I was talking about. That tube actually, we can get down to 8 inches in depth to scarify and blend the soil in place. So we manufactured all the rain gardens, bioretention rain garden soil on site. Setting the lower weir, fabrics. That's blended. That's now been blended. Now we're working our way out. No more equipment will go back there. So now it's set and ready for the next phase, which would be the stabilization and then large tree planting, stabilization with the matting, and then the plugs, but seeding in between. Sorry, seeding would come after the trees are planted, and then the matting goes on top. And you have to do all those things in sequence so you don't lose everything, because the storms that hit us fill those up, fill the basin up. So you can see our access point. This is a flow channel. So our machine, we could fit it in here, and that was our flow. That is where the water, you want the water to be, infiltrate and slowly release. And that's how we access through it and up. So that the largest portion of this wouldn't be impacted. The trees. That's how matting should look when it's installed. This is the stronger erosion control matting, permanent in the swale, and then the temporary matting in the basins. You follow the pattern, follow the staple pattern, and make it a little tighter. Overlap. Make sure you pay attention to which way you're running the fabrics. It's very important, and it's never failed on us because we've actually followed it. If you don't follow it, it will fail. If you're wondering why plants are popping it up, that's a problem. It hasn't been stapled correctly, because the seed then gets stuck in between the matting and the soil. Okay. And the swale, trees were planted. We stocked all of our perennials, all the plugs, and how many total plugs were there? Do you remember?
3,600.
3,600.
The main reason for the success.
Yeah. Stockpiled under a shady tree, and there it is. That's the lower basin with the outflow structure with the plugs planted and the trees. Is this the one? This is the storm that hit right after we did it. We fabric that. We laid all the fabric in a day and a half, correct? So when we did it, we laid all the fabric. We just hit it with a crew in a day and a half.
You knew the storm was coming?
No, we just, that's my job. Once you're ready, once you've raked it to the point and you seeded, you're done. You've got to get to the next step really quick. This job, and John will know, John knows this, it was a two to three man crew, and me, I was running back and forth the Stroud at the same time it was getting built. So 2 to 3 man crew built this entire facility. When I had to, we brought in up to a 5-man crew for something when we had to staple and do fabrics and do it quickly. This happened right after we did the fabrics, and we hadn't just finished the plugs yet.
So it was seeded, but the plugs weren't finished.
That's right. So there it is. These are all the grasses planted. Andropogon.
Yeah.
These are the andropogon.
And a little bit of little
And
blue stem. So it's a broom sedge and little blue stem mostly.
Right. So we also added plowing perennials into the to the basin's edges and in the basins, and also to the meadow that we built. So there, that planting was still going on. Edge reinforcement, you see the mower? We want to go that way, so we're reestablishing that, planting Magnolia virginianus and plowing perennials and grasses.
So no one told the lawn crew, I guess.
No, they did, but even with the cedar posts that we put in, we still would kind of go around. But they're working, they're getting better.
Yeah, we're a believe that the design should be such that they know where to mow.
They know where to mow. So
there are slopes, but there's a very aggressive, I could go on and on about this.
Yeah, I'm saying, so somebody wasn't just using it,
Yeah,
they were almost intentionally.
Yeah, oh yes, very smart. So, but I just look back, okay, this is what we have to deal with as designers, let's deal with it so that this will be sustainable long term.
yeah, I think it's important to know that, you know, when you have the funding, how you use that money, how you use that funding, how you build those projects. You know, planting and creating those edges, okay, maybe short walls per se, but that stops people from mowing it. If it looks correct and it's supposed to be there, they won't mow it. What happens is down here, but if there's a grass that tall, you know, if you see the height of the grasses along the edges, then you know. So here's a view looking from that trench drain, looking through to the corner of the school. But that's after it was finished in June, and that was in the fall of 2012. So less than, 7 months, 6-7 months. So I just wanted to show you some quick befores and afters. Started it, soils, fabrics, planting, and finish. That's July. Same thing, upper trench, weir, fabrics, finished in July. Projects experience success stories about where they work. Haverford Environmental Rec and Environmental Center in Haverford, PA. I worked with Chemical Grant. We were the landscape architect on that project. We did not build this. I got to construction, observed the whole thing, which was difficult to say the least. But so all rain garden systems, the entire site, all the parking lots are captured in swales, plugs and seed, same concept. Briarbush Nature Center, we did the rustic structure and we did all the rain gardens. There's 7 basins within a woodland, and we took 3 trees out and added 28 parking spaces, and they have a loop. And the entire core is for children. They get educated. They get off the bus and they go through the spine down into the entrance to the Briarbush Nature Center. So if you ever want to see it, it's kind of neat. There's natural playscape boulders throughout the whole thing. And then that's the rustic butterfly house that we've built. Penn State Harrisburg, we worked with Ms. Veridian. We did all the rain garden systems and plantings there. That's their student housing, freshman student housing, their new building. That was like 5 months after it had been done. Stroud this morning, just this picture. So, interpretation of drawings, making it happen, the stonework, we did all the stonework, and then that's what it looked like when we're finishing the layout, and that's what it looks like now. The same, almost the same view. Souderton Pool Complex, they have a new public pool facility. They're probably the only pool facility around right now that actually their entire, all the building drainage, all of the surface drainage, even the pool overflow goes through a system of this rain garden, of these rain gardens. Manufactured soils, the soils were not good. They went to a project they were doing, a tear down of a school building. So they actually, it was all within 5 miles of the site. So waste was low. But that was planted in July, and this is the fall. Huge system. All my pharmaceutical vegetated swales. A little different thing, under drain pipes. This all went to millions of gallons of cisterns. Their entire facilities and building used gray water for the toilets and the entire complex. Big. We still maintain this, and we built that for schools. What's important, collaboration between client designers and the contractor enabled a successful project. Bridging the gap, we always have the ability, it's good to have contractors that are knowledgeable. I know that there's times when there's low bid situations, we win those too. We just have to get to know everybody, what's the project, and understand it, and know that we can build it efficiently and cost effectively, which we have to do quite a bit in today's society. So, expertise and experience with previous projects informed this project. In other words, lessons learned. The project went well. It was designed well. The client was great. It was okay, but it worked well. I mean, we had a game plan. The construction sequencing, we knew what we had to do, and he was there, but every other day probably. He would always check once each morning. Alja and Melior were out. It went smooth. Pre-selection of contractors for bidding. We bid against 2 other contractors that were qualified. Careful sequencing of the construction enabled proper infiltration of the soils. Installing the soil erosion control fabrics quickly saved the project from we wouldn't have been able to, we would have had to pay us to fix it, because you can't anticipate that stuff.
And just from the engineering side of things, very quickly, some lessons learned was that the infiltration, actually, after it was built, was a little bit slower than we had anticipated. We had anticipated it would all drain down within a day, but it does pond for more like 2 days, which is still not a problem for mosquitoes. And then, as we mentioned before, the fabrics held up even during a torrential rain event, so that was a success story. We had wanted to maybe have an experiment in hindsight of showing different fabrics and how they would have held up, but we didn't have that opportunity. Even with a very gentle slope, you can still build these things. It just requires fine grading and careful construction. And even if you have tight site constraints, you can still build projects like this. You don't need a ton of space. You just have to be careful with your design and your construction again.
We did not take any soil off site. So the berm was built with the cut, and our soil swap for the sandy soils, everything. So I want you to understand something. There was no trucking, which was a major goal of the design team and John.
Big cost savings too.
That's right.
Yeah, I mean, you got more. You got a project.
Yeah. The plant species survival was very high on this project. Part of that is the maintenance. Also, I would go out and water. So it was dual. We had a reasonable rain. It was very interesting. Timing is luck. We installed some plants, and then a week later, the ones the volunteers installed, they didn't do as well. I know it was part because of the expert installation. I'm serious. And the volunteers don't always get them right. But then we hit a hard drought. And in just 1 week, it just luck sometimes. We also just kept it very simple.
we would water by letting the hoses actually sit uphill for the lower basins. Then you had to hand water, our guys hand water the plugs.
Using just grasses allowed easy identification of the weeds. That was a big part of the success story. Planting of plugs and plants just works way better than seed. One thing I didn't mention is that we also didn't use mulch. If you look in the standard detail of Pennsylvania, there's always a mulch layer. But every project I've been on before, the mulch washes.
Mm-hmm.
And so I spec'd, okay, non-floatable mulch, yeah, right. So I said, submit 3 samples, and I go into our kitchen and I float them all, and everything floats. So every project I've ever had, it ends up in the inlet, it ends up washing away. So here we used fabric and plants, and it's not part of the standard Pennsylvania detail, but it should be an option.
And that's all we use. Like when we design and build, even we recommended to the client, we use the fabrics. That Haverford project was the same way.
And it, like you said, we did save money. We saved about $30,000 on soils, because it can get very expensive trucking out soil and bringing in a whole new mix. And then just a little thing that I thought was interesting is you have the rain garden coming in, and you almost think like the bottom one might be the fullest of water, but no, we have the weir, and the one right before it was the wettest, and then the furthest one down. Got the least. It was counterintuitive but obvious. So it just should have informed our planting design. But our plants were such generalists and adapted to so many conditions. They did fine.
That had to do with the infiltration then on the different basins?
What it is that if you have like a half-inch storm, it never makes it down to the last basin. Yeah.
Basically, the system works ahead.
Right. Okay.
That's the simplest way to put it.
And it overflows after the 1.5-inch storm, or about the inch storm.
I
Right.
think the inch is
The inch
the,
storm.
Yeah.
And then that one slowly releases down below.
That's right.
And it works like it's supposed to work.
And lessons learned from Van Skyver partnership. We did have great local support. Sadler's Woods Conservation Association has been a great partner. Haddon Township, the project was part on Haddon Township schools. We solved the problem of theirs. They love the rain garden. There was one teacher who said that she just thought it was the best school property in New Jersey. She loved it. And the design does need to work long term. So here's the online resources for bioretention systems and rain gardens. And we have time for questions.
There's no another session, yeah, definitely. Because it is 3:30, but there's no other session, so.
All right. So if you had any more questions.
With the soil, do you do any surface prep, any scarification of the soil before you, I know you said you do that soil mixing on site, and is that all the prep you do? Scarification?
Well, no, the scarification does happen inherently when we use the soil blender, because it's actually a tube. It's on a hydraulic, right? So it's from here to here, and it spins at very, very high rate.
How big are those knuckles you mentioned?
2 inches, 2.5 to 3 inches. But it actually breaks and scarifies down, so there's no groove per se. You know what I mean? Like, because you can, with a backhoe,
So it kind of fills in as
you
it
know,
goes.
right. But the other part is that we were sure that we drove in, like I said, the conveyance system, the swale, which we had to come up with on the fly to a certain degree, which we would do anyways. But I mean, we walked through there and stayed on the berm, the walking trail, as much as possible, you know, to build our way out. So your equipment, you know, you were efficient with it. You had to be efficient.
It looked like you were challenged by the soil moisture content during that project.
I've learned over the years that it's soil. It's going to get wet. It's going to get muddy. Just don't let it stress you out.
They did all their heavy construction in dry weather.
Right, we did. All the heavy construction was the excavation and the soil swap. We did it when we could, you know. And then when it was wet, I worked on the masonry stuff. You know, so it dried out quick. So it actually did dry.
If it rained during spring break, you would have had to.
That would have been a problem.
Yeah, we worked pretty closely with the school and township, right? I mean, they were very good about the whole thing.
That's right. They would have understood.
overtopping spillway, emergency spillway, whatever you want to call it, what kind of design storm do you use for that?
I can't recall off the top of my head. I think that we just wanted to provide enough space to have some way for water to get out, but I don't recall the size storm that we planned for.
Okay. Your outfall structure then between the cells, that was a perforated pipe, T lateral on the upstream side, T lateral on the downstream side for discharge.
Like a spreader, that's right. And then
Yeah, that's only in the last pool.
That's
Yeah.
right.
And in between all the other pools, just the earthen berm allows water to flow over. So
Earth and stone.
Earth and stone, right, right.
So that is designed to overtop then?
Yes, yes, the water will flow over the stones. There is not an under drain or anything between, so it's either it infiltrates or is evapotranspired, or it moves out through the very last basin.
You have any problems with children or something coming along and moving stones on you to create
Yeah,
a preferential
yeah.
flow path?
I forgot to mention that.
Erosion
Oh, real minor.
Yeah,
The
little
big
bit.
stones aren't going to be touched.
Yeah.
The little stones in the back, kids throw them.
The big stones are, 2 tons, 1.25 ton. Yeah, they're solid pieces. They're not
That's what I
going.
said. I've used concrete barrier buried for weir sections like that, and they don't move.
Yeah, the nice thing is
those.
those were large slabs that
Yeah.
we used and put them into place.
Yeah.
But I agree. The
Nice
only
and
thing we
good.
had problems with is the rock filter, but we resolved that by using a GeoWeb. This fall winter, we installed a GeoWeb and tucked it into the back under the stone.
Right.
And lays right over top now on both sides. And that's pretty much resolved that and added a little bit that has been thrown into the woods. But the overflow, though, if you look at the picture, and that was a big storm, the water was going through the overflow. That overflow it wasn't reaching the banks anywhere else. So it worked.
Right.
It definitely did work.
Can you elaborate a little bit about your uphill under drain? How much difference in elevation?
Uphill under drain.
You mean where we dug the trench?
No, we had that pipe with the silt sock, and you're saying you.
Oh,
I
that-
think
that's
that
a
was just an
different.
example from a different,
Different project.
Yeah.
but did you want more?
Well,
detail?
just how much elevation difference?
Oh, I know what you're talking about, thank you, yeah.
It goes up.
That was about 4 feet deep, and the outfall was about this far down. So we would have about 2 feet of aerated soil and potentially 2 feet of saturated soil, which the plants can handle.
Did you have any issues with settling after that soil was put in the storm? I don't know, directly after that, the basin might settle a little bit or anything like that?
No, we typically have learned that we need to anticipate that. So we know that inherently you're probably going to have anywhere from 1 to 3 inches of settling, depending on what you're doing with the soils. So we actually did, it's fluffed.
Yeah.
So you know that when it's fluffed, you rake it out. And we wet it down too, a lot of times to start to get it to go down. And plus or minus a half an inch sometimes. There's some valleys, it drains pretty well.
It does. We were very fortunate on this. I'm a landscape architect too, and so just from the experience, knowing this site, we didn't have to follow the standard details of treat for the soil. It's soil and it drains. All we had to do was blend a little. And one reason we specified the blending in the top was to make sure that whatever contractor we ended up with, the last thing they do is fluff up the top. We just had to get the water down to that low area, and it would infiltrate. So we were just very fortunate on this project that we had great soils in the back. We just had to do a little bit, and it saved a ton of money.
And the plants break up compaction. You got to remember those general plants. They're soil busters. There's a lot of good things that are going to come out of that. I think the infiltration is going to change more over the next, 2, 3, 5, 10 years with the system. It's only going to get better, in my opinion.
That's right. So the warm season grasses send down roots.
I like the idea when you said when you did the plant installation, you did the grasses, all the grasses first, so it was easy to ID and monitor and do the weeding. And you might have said that, I might have missed it. How long? What was the time frame between putting the grasses in and then putting the perennials in?
It was about 1 week, but what we made sure to do was put in 4-inch potted perennials. So the perennial's this big already. When they sprout, the leaves are different. So if it was a plug, the leaves look different than the final plant. So we made sure each plant was about a foot high. So then it was easy to identify those plants.
And
anything that didn't look like that.
And when we weeded, John was there, because there were certain ones there are certain ones, do you want these out or not? Because you get a lot of things coming in, okay? So our guys were doing, our crews were doing it. We maintained it through a certain point to get it established so that you didn't have any of the real bad guys, invasive plants. So there were certain things we decided to leave.
Yeah, so it's a judgment call from experience. So I pulled out the ones that I thought were worth it because you have the data to do the work.
And some, if you pull, you actually are doing more damage than it's worth. Because the seeds, what was the one?
Nutsedge.
Nutsedge. If you start pulling the nutsedge, it's only going to grow more. So
we left it.
We left it.
It'll get taken over by the warm season.
I mean, those grasses were DP38s from North Creek. Give you any perspective, and they were this high and this full by this fall.
Yeah.
It's smaller is better in that case. They'll get established quicker. Again, water. You're going to need water at certain points because it gets so hot. We hit that in the right season though too. It was planted before June 15th.
And how densely did you plant them from the center?
They're 2 feet, maybe.
2 feet.
They were different. You can't tell them there, but
that's right.
There were drifts and everything that we tried to pull off with John. We laid everything out. Everything got laid out by tray, by plant. So the entire site, and that's typically, the way we've been taught, and we've been doing it for, a couple decades now, right? So works out better. We moved a lot of trees for John. Even when I laid them out, he's like, "You think you can move that one over a little bit?"
You have trouble with plugs heaving in the frost?
You will have trouble with plugs heaving in the frost if you planted them too late.
How late is that?
Well, roots can still establish, but mostly the plants are dormant from early fall on. So you would need to plant. We planted gallons in that case.
So yeah, so we made sure because we were worried because they planted it in basically January.
Yeah, we actually planted that the last week in January.
So we made sure to go in with gallons so that we pop.
But plugs will pop.
Oh, time to go.
Thank you, everyone.
Thanks. Thank you.